Today I want to show you how to design a subplate like this one. Can be later used on a Snapmaker Artisan as a base. This flat surface is a good base to mill precise aluminium parts later on, like shown in this example here. This is the start of a journey I want to take you with me of building your own do-it-yourself 5-axis module for the Snapmaker Artisan. I'm also very excited to share that Snapmaker itself has seen my efforts and is actively supporting me in my work. Let's create the design. We start by creating a new file, hybrid design. I will come back later to why I choose hybrid design. We create a sketch on our XY plane. We will use the rectangle, the center rectangle, to draw it out from the middle. We will make it 118 times 380 millimeters. Finish the sketch. Then we extrude it to 30 millimeters. Next, I want to place some points. I use the point function here, place them, make the origin visible, so I can use the function symmetry and make these points symmetrical to the center of the part. As I have done it here, now you can see they are connected and all moving. Now let's set the correct distances, so it's 300 millimeters times 100. This will match perfectly with the CNC board from Snapmaker. And the next thing we want to do, make these points to actual holes, so I select them. I will select all here. I will select counterbore and clearance. I will choose the M4, switch back to simple so I'm able to adjust these values. I want to make it deeper, so I will make it to 8 millimeters deep. And I will also set the smaller diameter to 5.5. This is critical, the 5.5. If you go lower than this, you will have problems with the end mill that I propose to later manufacture this part. On the back side we will also place some holes. Again, the same procedure. We choose point, place them. In this case I want to set the first one 30 millimeters distance in X, the other one 20 millimeters. We will make this distance 50, and there's a small trick, so this one should also be 50, so the same, so we can place it. Just click on the other one and then it will automatically take this if we press enter. Finish the sketch, then we also make holes out of it. This time I want to set distance. I want simple, simple and flat. I want this to be 6 millimeters in diameter and 9 millimeters deep. These holes that I'm placing here are later used with dowel pins. This helps us later to precisely position the subplate on the CNC board. Let's continue. We place 4 more holes with point again. Make them symmetrical again. The holes I'm placing here are used as temporary fixing solutions, so we are able to mill this subplate from both sides. We want the subplate to be perfectly flat on both sides, so we don't have any wiggling from subplate to CNC board. We just want a very stable flat surface where we can later mill precise parts on. Let's finish this up by using the same function as before, the hole function. We select all again, choose counterbore, clearance, the M4 again, switch back to simple so we can adjust these values. Again, this to 8 and the diameter to 5.5 millimeters. So that looks pretty good so far. I want to, I forgot something. Let's put 2 more holes. I want to put M8 threads here. These M8 threads should later help you remove the subplate from the CNC board, because once you use the dowel pins and the subplate is screwed onto the CNC plate, it's not that easy to get off again. We want a very tight tolerance. That's what we want to have it precise, but this also causes us to have difficulties to get it off. Placing these M8 threads allows us to use screws to just help with screwing the screws in to kind of lift the subplate from the CNC board. So here we choose all again, but this time we choose hole type thread. We choose the M8, so 8 millimeters. Press OK, and this is done. Lastly, what I want to do is I want to add some chamfers on the side, so I select these edges. The last one in the back, let's say 2 millimeters. That looks nice. Press OK, and that's so far for the design process. I also welcome you to check out my website. You will find different topics there, like specifics on how to mill aluminium, some references and explanations to the different kind of tools you can use. There will be also more advanced stuffs like the machine simulation. This I have provided in a step-by-step manner, so you can follow it and actually apply it on your machine. The cutting parameters are not just simply thrown at you, but also explained in detail. Furthermore, I also provide references where you can find raw material or end mills, and much more for you to explore. That's all for the video for today. I hope you liked it, and I would be glad to see you in the next one. Bye!